Hey guys, welcome into the Wells Tech Garage for this month's training class. Today we're going to be talking about our GTO. We're finally going to be fixing it. I'm going to show you guys some different testing procedures and some tricks, I guess, to perform when you're looking at rich and lean conditions on your vehicle. So, first of all though guys, I do have a lot I want to talk about, so I'm going to jump right into the t-shirt question. That's okay. It's okay. So we're going to jump right into the t-shirt question today, guys. Now, I got something a little bit different this time. So we still have our shirts, like always. You know, Wells Tech shirt, either gray, blue, or black, if you answer the question correctly. But also, new, the Wells Tech hat. Okay, so you can win a Wells Vehicle Electronics hat, just like this, if you answer this question correctly. Now, being that we got something new this time, I wanted to make the question a little bit harder for you guys. And, well, here it is. Technician A says an EGR valve that is stuck open will cause a rich code. Technician B says an EGR valve that is stuck open will cause a lean code. Now, this time it's not going to be a simple Tech A or Tech B. I want to also know why. Why is it doing that? Why is it setting a rich or a lean code? Okay? So go ahead, submit your answers with which technician is correct. And yes, one of them is correct. Submit your answer. Either chat it in here in the chat box or send me an email. Because this one's got a little bit of typing involved and telling me why, I'll give you guys till the end of today to send me out an email with your answer in it, okay? So today, April 6th, anybody who sends me out an email with which one is correct and why can either win a hat or a t-shirt of their choice, okay? So we'll bring up the answer or talk about the answer later on at the end of the class. Alrighty, so let's get to the GTO. Now, the way I want to treat this today, guys, is just like anybody else in the shop. When this vehicle comes in, it came in with a check engine light. So we're going to start at step 1, and we're going to work through it all the way to verification of the repair. Alright, so stick with me, guys, because I'm going to do some tests that you probably already know and do every day. But for the beginner guys out there, the do-it-yourselfer, it's going to be a good lesson for them. And then we're going to get into a little bit more in-depth testing or some things that you might not perform on every situation. So we'll do the tests that are pertinent to this, but then I'm also going to add in some other things. Okay, so let's take a look at our scan tool and see first of all what we have for codes. So I already have it booted up, and I'm going to go into display codes. And let's see what we have here. All powertrain codes, and right away, just like we talked about back in January, this thing is running lean on both banks, bank 1 and on bank 2. Okay, so this is already telling us information that we want to know. It kind of gives us, you know, we have a fork in the road and we got to choose a path here. Are we looking at a single bank problem, maybe a stuck closed fuel injector, a non-functioning fuel injector, making the entire bank off on just one side? Or are we looking at an entire engine problem, maybe a vacuum problem, a breathing problem, something going on with that? Being that we have a code for both banks, we're going to be looking at the engine in its entirety, right? We're not going to be just looking at a single bank, okay? But now we can go one step further with this. And actually, what these two codes right here, 171 and 174, are the generic mandated by OBD2 to pop up on your car. Now, there are some European models out there, and I wish I had some screenshots for you guys, but unfortunately I don't. Keith, Onboard Tech 333, had commented in on one of the videos saying that he'd like me to talk about additive and multiplicative fuel trims. That is a European thing. So if we were to pull codes on this engine right here and it was a European model, you might see some P1000 plus codes in there, and it might say something like fuel system to lean additive or add, or fuel system to rich add, or fuel system to lean mult or multiplicative. What that basically means is the manufacturer has thrown some codes in there to kind of give us a direction to go at our fork in the road. Additive fuel trim failure is a fuel trim failure that is happening at idle or closed throttle. Okay? That is going to be a problem such as a vacuum leak or something like that. Multiplicative failure, or a code for multiplicative fuel trim failure, is going to be something that is going to happen off of idle. So under load, driving down the road, maybe on an on-ramp or something, one thing that comes to mind right away for me is a fueling issue, where you're not able to get enough fuel under load. So something like that could be cause for a multiplicative code. So additive, multiplicative, just kind of narrows down or gives you direction at which path in that fork to take. What we can do, being that this is well, I'll call it a domestic, even though it's Australian, but we'll call it a domestic because it is a Pontiac. We can go into freeze frames, and we'll check our freeze frame records for this engine. Now I'm just going to check one of them just to help save some time here. We're going to have freeze frames for both, bank 1 and bank 2. Let's just grab freeze frames for bank 1, and let's just take a quick peek and see if we can figure out some sort of direction that we want to go here. All right, so we get all this data up here, and sometimes you'll see more, sometimes you'll see less in terms of data. There's only a certain amount of PIDs that are mandated via OBD2 for freeze frame data. Some vehicles you'll see more, some vehicles you'll see less. So what I'm looking at first of all is engine load, throttle position, and RPM. This is telling me right here, 633 RPM, 0 throttle position, engine load 1%. I'm thinking this thing is at about base idle as it can get, right? So our fuel trims right now, short-term bank 1, positive 20. Short-term bank 2, positive 25. Long terms on both banks, positive 25. So what is this telling us? This is telling us our engine is running completely stupid lean, right? It's to the point where it's maxed out the long terms and it's still adding on the short terms. The short terms aren't even able to make this thing happy yet. So what does lean mean? Lean is excessive oxygen going past our oxygen sensor. Now that could be because of a lack of fuel. That could be because of a lot of other things. Remember, rich is a lack of oxygen past the oxygen sensor. Lean is excessive oxygen past that oxygen sensor. So right now, our O2 sensors are probably pegging pretty low. I don't think we have O2 sensors in here. But if we did, I would expect to see our O2 sensors probably pretty low in voltage when this code happened because there was excessive oxygen passing that oxygen sensor. So what does the computer do? Increases the pulse width on the injectors and dumps more fuel into the engine. Okay, so we know now that our problem is at idle and we have it severely lean. Now there's a couple other things I want to check out. Baro and coolant temp are big giveaways. Our coolant temp right now, 185 degrees. So our engine is currently warmed up. It's not cold, it's not ambient temperature, it is definitely warm. Our baro, 29.2, looks pretty normal. Baro is going to be something that's going to change depending on where you live and depending on the day. You can always check out your local weather site to find your baro reading, but you want to just verify that your baro is accurate. And all right, I think the rest of this looks pretty good. Yeah, so now at this point, I'm starting to think already in my head of which direction I want to go. And from experience, looking at these freeze frame information here, I am going to pursue a vacuum leak because to me, that's probably what's going on with this thing. Now, we could have other things happening, that's true, but from experience, from looking at this, I would be first of all chasing a vacuum leak. Now, there's multiple ways to go after a vacuum leak. Well, actually, let's back this up 1 second quick. I do have the scan tool already hooked up and the key on, so why don't we just look at current data quickly and make sure that our current data is accurate. It looked okay inside of our freeze frame there, but just let's make sure that our current data is accurate because remember, fuel trims are not there's not a fuel trim sensor. Remember, it's all calculated. So if you have one of those sensors that's being used in the calculation and it's skewed, it could set your fuel trim issues. Now, it didn't look that way in freeze frames, and I don't think it's going to look this way in live data. And another tip is if you have a skewed sensor, chances are it's probably failing its own test, and you'll probably get a code for like a map sensor, coolant temp, something like that. They will usually code before fuel trims, but anything is possible. So let's take a peek at what we have for current data, and this is live right now. So right now we are sitting at long terms of positive 25 on bank 2, positive 22 on bank 1. Short terms, because the engine's not running, our short terms always go back to 0. Our long terms are kept. So our long terms are definitely lean, and I would expect to see our short terms will probably go up after we start this engine up. So there's a couple other things I want to look at here. Coolant temp. Right now our engine's roughly pretty cold, almost ambient temperature, 89 degrees, looks normal. What I'm looking for here is maybe like a -40 or a 232. You know, that failure mode for the sensor will typically fail high or fail low depending on the failure. So right now that looks good. We can take a look at intake air, 80 degrees, that looks good. And just take a quick peek at our barrel, and 28.9 seems pretty good. It's a little bit lower than that 29.2 of what it originally read, but we're probably okay there. And because the engine's not running, everything else looks okay. So now at this point, again, we're going after a vacuum leak. Now let's say we know that this engine is failing when it's warm, okay? But commonly, vacuum leaks fail when they're cold, right? We've all run into it, intake gaskets leaking when they are cold. So what is something that you can do before you ever fire this thing up and warm it up? Because remember, when you warm up an engine, metal expands. You could seal up that gap that might be in there. You could seal that up by the metal expanding and get rid of your vacuum leak. Now, that's not the case on our GTO because it's got a pretty nasty vacuum leak, but on a vehicle that's potentially borderline, you might see in your freeze frames that coolant temp is, I don't know, 100 degrees and it's failing. And then you bring it into the shop and it's warm, the customer just drove it in and it's not failing right now. What can you do at that point? Well, you could let the engine cool down and you could smoke test the intake manifold and the entire system. Remember, we're looking for vacuum leaks. We're looking for some sort of unmetered air entering into our engine here that is after the mass airflow sensor. So if we take a peek here, we can see our system. And remember, this is an entirely closed system. Our mass airflow is right here, okay? So anything from this point till it gets into the cylinder needs to be sealed up, right? Because the mass airflow monitors that air flowing through into the engine. If there's air entering into this engine from anywhere else after this sensor, we're going to have a vacuum problem, a vacuum leak. So what can you do? You can get out your old smoke machine and you can plug it into one of the vacuum ports on the intake manifold. So that's what I'm going to do. I just got a little nipple on the end of this thing. I'm going to pull one of the big vacuum hoses off the side of the intake right here. Try not to drop it. And I'm just going to plug this guy in right away. There we go. So she's plugged in. And we'll turn it on. And now this is a high flow unit. This thing is able to pump out quite a decent amount of pressure. It's not an evap smoke machine. You could do this with an evap smoke machine. It only puts out 1 PSI, 1.5 PSI, something like that. So it's harder to find. This thing's putting out, currently we're pumping about, what is that, about 8 PSI into this intake manifold right now of pressure of smoke. So what we're looking for is this smoke to start coming out somewhere. Obviously the smoke machine needs to warm up, get that smoke pumping out. But eventually here we're going to see smoke coming out of our air box over here because I didn't seal anything up on this end. If we were to look at this thing right now, we would want to seal up our throttle and air intake snorkel right here. So right here is where our mass airflow is. We would want to seal this off right here and put like a plastic bag or something right in here to not allow the smoke to exit out of our air box because it's always going to flow past the throttle body through here and out into our air box. Now fortunately this thing's leaking bad enough that I can show you guys without having to go through that step. But if it's a very small leak, you'd want to put like a plastic bag in here, put this back over it, tighten the clamp down and seal off this side of it. And then from there, you start looking for the leak, okay? So I got my flashlight here, and let's see if we can find a leak. So what I'm going to do now is I'm going to start looking for any smoke trails along the mating surface of the intake manifold and the cylinder head, right between there. We'll go down bank 1 here on the driver's side, and I'm not seeing anything. Let's go over to bank 2, start at the front, and again, we're looking between the cylinder, move my flashlight, the cylinder head and the mating surface of the plastic intake, and there I can see some smoke. So I'm not sure if you guys can see this yet, if it's dense enough smoke yet. Might be kind of hard to see. Maybe. Let's see if I can watch it with you guys and see what we got here. Oh, yeah, I can see it. So I hope you guys can see it. It's coming out right here. Look right in front of my finger there. You can see that there's a little puffs of smoke coming out of there, right? You can see how it's kind of fluttering past there. That is smoke leaking out of this intake manifold. So there's definitely a leak. And our leak is big enough on here that it is actually coming out very, very rapidly considering we haven't plugged off our air box yet. Okay, so at this point, if you're a technician in the shop, I'm putting intake gaskets in this thing. or an intake manifold, because it's either one of two things. The intake gaskets have failed, or the surface has warped and I guess caused the intake gaskets to fail. Okay, so now we will get to that. I am going to pull this, Fritz is going to help me pull this intake manifold off in just a few minutes, but there's a couple other tests that I want to perform before we get there, so that you guys can be looking at other problems on your car if it wasn't as simple as putting a smoke machine on it. They're not all this easy, okay? So why don't we go ahead and let's use some propane. Let's enrich in this thing and give her some gas and see if we can get some changes on our fuel trims. Fritz, you want to come on out, and I'll have you fire this thing up here in a sec. Actually, what I'll have you do is, yeah, I'll have you fire it up, and then I'll have you run some propane along this. So what we got here is just a tank of propane and a hose, and what we're going to do is we're going to run it along the intake manifold, right where that smoke was leaking. We're going to run it right along there and try to get the fuel trims to change, try to get our oxygen sensors to change. So first of all, I'm going to get the scan tool set up, get that all where I want it. So now we're on live data, key is still on. So I'm going to go and I'm going to make a custom graph, so I only want to look at a few things here. So what I want to look at, let's look at bank 2 sensor 1 and bank 1 sensor 1. So we're looking at our oxygen sensors. Let's look at all 4 of our fuel trims as well. So we got long-term, short-term, and long-term and short-term. And I think that's probably enough. We can, let's just throw RPM in there too, just so we know where we're at for RPM. Bring it up into graph view. There we go. Now it's going to get loud when this thing's fired up. It unfortunately doesn't have any mufflers on it, so I'll try to talk louder over the car. But let's see what this thing looks like. Go ahead, Fritz. All right. So that's some great American power right there, right? 5.7 liters of race car. All right, so I want this thing to go into closed loop first. And actually, it would probably be a good idea if we included in our custom graph the loop status. So open closed loop, I'm going to go ahead and graph it again. And what we're looking at now is open or closed loop, and we're going to monitor our oxygen sensors and our fuel trims, okay? So ready? Nope, just hang on a second here. We're going to wait for this thing to kind of start correcting. So you can see already our short terms are starting to go up, just like I thought they would. They're going to increase because we have a vacuum leak. And actually, let's plug this hose back in. So you want to just take that down for a second. So I did leave the hose off that was on our smoke test. So let's plug that back in and see if we can get this thing to run a little better. There we go. Okay. So now you can see we got a good old pyramid on our graph here. We were leaking really bad when I had that hose off, and now it's starting to come back down. Our RPM changed, and we're still in open loop, so hopefully this thing will eventually enter into closed loop. Any minute now. Our oxygen sensors have started responding. We're seeing them switch back and forth just like they're supposed to. And I guess we're still in open loop, kind of odd. I expected this to enter into closed loop already. It looks like our short terms are responding properly. Why don't you go ahead and add some propane, Fritz, and see what happens here. So you're going to go around bank 1 right now, which didn't have any smoke leaking. And I'm not seeing anything yet. Yeah, bump over there where we saw the smoke. You got any flow coming out of there? So our sensor should peg rich, and we should go negative. Maybe it's not flowing any propane yet. You feel it? Did we grab? Oh, there we go. It just went into closed loop.
I got it wide open.
Okay. Maybe we grabbed a bum propane tank. Oh, we're starting to do something now. There you go. So we can see that our fuel trims are starting to go negative, especially on bank 2. And this is, this is right here. This is bank 2 right here. This is bank 1. So we're on bank 2, and we're seeing our fuel trims adjust as Fritz is feeding this thing with propane. Go ahead and Try and get it a little closer to the intake one, see if it'll suck right in from there. There we go, so it's starting to tick down negative again. All right, you can go ahead and shut that off. If you don't have a can of propane or something like that, you could always use a good old can of brake clean. All you're trying to do is add fuel at this point. Now, be very, very careful when you're adding brake clean. Again, we talked about this in a different class. You don't want this near any sort of ignition source, so let's add a little bit of this and watch on the scans. We'll see what happens. Go ahead and bring that up. There we go. Let's spray some in here. We can hear a little bit of change in the motor, and there we go. We got bank 2 running rich, so the short terms are going negative. Okay, I think you can go ahead and shut it off. But first, let me just pull this fuel pump fuse. Actually, you know what? No, we'll leave it on. Go ahead and shut the car off. And I'm getting ahead of myself here. Okay, so now hopefully you guys can hear me decently again. So now, that would be, again, just another way to find our vacuum leak. Our intake gaskets are leaking on this thing. We know that at this point. But let's say this problem occurred under load. Let's say we had an issue under load. Our engine leaned out, wide open throttle getting on an on-ramp. The thing would lean out and run like crap. Well, that could be because of a lack of fuel. So unfortunately, this engine does not have a fuel rail pressure sensor. It's got, like a newer vehicles, most of them run fuel rail pressure sensors now. This one does not, so you got to get out the good old manual gauge and check your fuel pressure and verify that it is accurate. So I'm going to go ahead. This one, though it might not have a fuel pressure gauge, it does give us a really nice port to hook up to. So right here on the end of the fuel rail, I'm just going to thread this guy in here, hopefully not make a mess, and hopefully not cross-thread this. There we go. Thread it down tight. All right. So now, Fritz, I'm just going to have you cycle the key a couple times because I just took the prime out of the system. So go ahead and cycle it a few times, and we should see our gauge spike right up. Okay, there we go. You can leave it on. And make sure you guys can see it. Key on, engine off. We're at, what is that, about 56, 57 PSI of fuel pressure, maybe 58. All right, so that looks good. Go ahead and turn the key off, Fritz. And now we should expect to see this maintain fuel pressure, right? Fuel is supposed to stay in the rail after the key is shut off. And it looks pretty good. Now, if this wasn't maintaining fuel pressure, if this car came in for, let's say, a rich concern, I would do this test because you could watch for the injectors to be leaking, right? So rich concern, maybe you have an injector stuck open, maybe the pinto's stuck, there's a piece of something in there, dirt or something causing it to get stuck. As soon as that key is turned on and then back off, your pressure on your gauge would drop, right? Because it's leaking down into the cylinder. Either, well, one of two directions, either into the cylinder or the check valve in the fuel pump is bad and it's leaking back into the tank. But if you're running into a rich concern, verify fuel pressure and verify that it is not leaking down, okay? So let's fire it up now and see, just for spec guys, fuel pressure on this thing is 55 to 64 PSI. Let's go ahead and fire it up and make sure that our fuel pressure is good to go here when it's running. I'll hold this up in the camera again so you guys can see it. There we go. So you can see we're, what is that, about 61, 62 PSI. Looks pretty good. Give it a little gas. And as you can tell, it's got that nice raspy straight pipe sound, but our fuel pressure was pretty steady. Go ahead and give it one more time. All right, that looks good. You can go ahead and shut it down. So what we want to do here, and now guys, by no means is this the best way to check for fuel volume, but we're trying to verify that the fuel pump is able to keep up when the engine is asking for more fuel demand, right? Engine RPM goes up, we need more fuel. So by revving it up like that, we're able to watch that the fuel pump is able to put out enough volume and maintain that pressure where it's supposed to be. If you saw that dip off, you know, maybe 40, 45 PSI, you might have a plugged fuel filter, or the pump is starting to go bad. The best way to do this would be driving down the road, open the thing up, maybe wide open throttle, make sure the fuel pump can keep up. Now, unfortunately, we're not on a dyno. I can't take you guys down the road with me yet. Maybe someday when technology advances, I can stream live from the road. But as of right now, this is all I can do for you guys. But at this point, I'm not looking at fuel being an issue on this engine. We're in spec. It seems to be in spec when it's revved up. But again, checking under load would be the best way to verify that the fuel pump's able to keep up. If you're questioning the fuel pump, then at that point, you could go ahead, throw a scope on it, and measure the fuel pump with the scope. Now, I'm not going to get into that today because I want to save that for another class when we do some fuel pump diagnostics down the road. So fuel, good to go, right? You check pressure, you check volume, you're good to go. But there's one thing that a lot of people tend to forget, and that is fuel quality or fuel content or ethanol content in the fuel. It's something that's pretty commonly overlooked, but something that we see pretty often acting up and causing issues on our vehicles nowadays. Because when you go to the pump now, you got how many freaking different choices? 85, E85, 87, 89, 91, 93, diesel, no ethanol, added ethanol. You know, there's so many different choices there. It's not too hard to pick the wrong one. So why don't we go ahead and check out our fuel content on this engine. Let me grab a container here. And what I'm going to do is I'm just going to bleed some of the fuel off of our gauge here into a cup. Go ahead and turn the key on a couple times. And I'm going to grab some fuel out of this thing. And all Fritz is doing is just keying on, and when you key on, the system primes itself. So I think that's about enough. Shut this off, try not to make a mess. All right, so I got some fuel in this cup right here. And what I'm going to do is I'm going to put this into a graduated cylinder. Now this here is a graduated cylinder. Now you don't have to buy anything fancy for this. You don't need any sort of scientific equipment. Graduated cylinder just means that you need to have something with equivalent lines on it, okay? Something that you can measure with. Now, what you want to do is you want to take any sort of container that you have that is acceptable to put gas in, and you want to put 12 lines on it, 12 equally spaced lines on it, okay? So what I'm going to do is I'm going to dump fuel in this thing until it's up to the 10th line. On this, it is 100 milliliters of fuel. So I'm going to go ahead and dump this in. And I'm sorry, guys, that you can't see this, but it was better that I do this like this than spill gas all over the place trying to show me dumping fuel on camera. Okay. There we go. So now I have 100 milliliters of fuel in this glass right here. You guys should be able to see that now if the camera's working. There we go. So this is the one I just filled up. This here and this here are, we'll get to them in a second. But here we got 100 milliliters of fuel in here, okay? And you can see somewhere here's my black line, there we go. 100 milliliters of fuel. So now what we want to do is we want to add some water to this, okay? Oh, there goes our CO monitor. You might hear the fan kick in here, guys. So what I have here is just a thing of water. I put some blue food coloring in it so that you guys can see it easier. But what I'm going to do is I'm going to add 20 milliliters, or 2 of those tick marks worth of water to this. And we'll dump it in here and make sure that I, again, try not to spill all over. Okay. All right, so there you can see now that we should be at 120 milliliters, right? 20 milliliters of water, 100 milliliters of fuel, 120 milliliters. Now, as you can see, gas and water don't mix, right? I mean, we all know that already. You can light gasoline on fire on top of water. I mean, oil rigs and that kind of thing, we've all seen that in the movies, right? So we know that already. So what I want to do now is I want to force them to mix, okay? So I'm going to take and put a cap over this, and I'm going to shake this. You could stir it, do whatever you want, but I just want to get everything mixed together here without making too much of a mess. All right, get that all mixed together, and this will build pressure when you mix this, so be careful if you have a perfect seal. And we'll set this back down. Now, the reason why there's going to be some change here, maybe, is because ethanol in fuel is alcohol, and alcohol absorbs water. So if we have, let's say, 10% ethanol in this fuel that we're testing right now, I would then expect to see probably about 30 milliliters of water and only 90 milliliters now of fuel, because that ethanol content was pulled out of the fuel and is now part of the water. So let's take a look and see if it started to separate out a little bit. Let's see what we got. All right. And well, look at that. It is at almost 30 milliliters worth of fuel. Now, that's interesting because this is premium gas in this engine. Now, premium is supposed to be no ethanol, at least in most of the areas around here it's no ethanol, but apparently, pulling this out, there is ethanol in this fuel. If we look at it again, you can see, here, let me grab a little pointer so you guys can follow me here. So 100 milliliters, 120, and down at the bottom here, might be hard to see, but this line right here where this blue is 30 milliliters. So right now, this is about 10% ethanol in this fuel, which is pretty common for base 87 octane that you pull out of the pump. So for whatever reason, this thing is not running premium fuel in it, or it's premium fuel with ethanol in it, okay? So let's take and do this one now. So this here, right here, is 87 octane pump gas that I just pulled out this morning out of the pump, and in the time that I've been talking now, it's actually evaporated 10 milliliters. So it's going to throw our math off a little bit here, but I'm going to go ahead and dump some in. And now, guys, there is no, I don't know, I mean, if you're really trying to figure things out and really try and nail down 10% ethanol versus 20% versus 15, you want to be very accurate with this. But at this point, what I'm trying to check, is there any ethanol content? Is it about 10% or is it E85? Now, I don't know that you need to be, unless you're a scientist, completely accurate with this, because what we want to do is just verify that it's not E85 pretty much. Okay, so I shook this one up and it will settle in just a few seconds, and we'll see what that looks like. And we're starting to see it settle out. Go ahead and go to that camera. Now, I did lose a little bit when I was shaking that. And again, we're right around that 30 milliliters mark. I did put in 20 milliliters of water. I filled it up to that 110 mark. So we're still sitting right around 10% ethanol in this 87 octane pump gas that I pulled out this morning, which makes sense. The sticker on the pump said up to 10% ethanol. Okay, now this kind of clear, not really looking like gas liquid, this is E85. So what I'm going to try to do here, guys, is I'm going to bump this one over here. I'm going to show you guys, as I dump the water in here, what this actually looks like. So let's go to that camera, and I'm going to try to just watch. This is going to be hard to do. I'm going to dump this in here and try to get it right at that 120 mark. Probably right about there, huh? A little bit more. But look at the difference already, guys. I'm not even shaking and stirring this thing yet. Look what we got here. So that's about 120 or so. So you can see, look how cloudy that is. Look at how milky it looks, how faded the blue is. And that's because at 85% ethanol, that is absorbing into that water, spreading the food coloring around inside of there, and mixing together. Now, I'm not even going to stir this one. Let's just watch it settle. And you'll see right near the top, a line starting to form right about there. You can see our line. So we have some actual real gas inside of this thing sitting on top of our ethanol content, okay? So that is a simple, easy way to check out your ethanol content inside of your fuel without any sort of special tools or kits that you got to buy. I mean, I went to Walmart and picked these up for under $2 a piece. So that is an easy way to check for ethanol, and I mean, if you're thinking that there's ethanol in it, it'll definitely change the way the thing runs. Okay? So that's fuel. We nailed out pressure, volume, and ethanol content. Let's go to something a little bit more abstract of a test, I guess. This is not something that you're always going to be performing, but I think something that's vital for you guys to know. So first of all, I'm going to go ahead and grab our gauge off of here, get this out of the way. Now, Fritz, can I have you, I'm going to have you fire this thing up, and I'm going to disable fuel on here now. Go ahead, fire it up. I'm going to pull the fuel pump fuse. All right, good to go. So our fuel pump fuse is currently out. It sounds like our battery's getting kind of weak. You want to run around to that side and turn the charger up? The battery's getting kind of weak on here because the key has been on for so long. But okay, so now what I want to do is I want to do cranking compression. And this doesn't sound like something that you would do very often for a lean condition or a rich condition for that matter, but it's something that you should know how to do because there's going to be times when you're going to need it. Timing being off, variable cam timing motor, actuators, or phasers getting stuck on the motor. Ford 5.4, perfect example. You have one bank that's off, right? So you have one bank that's less compression. That would cause the engine to either run rich or lean, or more compression, depending on how it's failed, will cause it to run rich or lean. So you can verify that really quickly with a cranking compression test. So what we're going to do is we're going to grab an amp clamp, and just got this is a 2000 amp clamp because I want to be able to, I could see the peak of the starter draw with this if I want. But all I want to do is I want to take this and stick it right around our positive battery cable. All right, go ahead. There we go. Around the positive cable. Get it out of the way of everything. Make sure I don't chew it up with the belt or something like that. And I'll hook it into our scope. All right. And then, so we got an amp clamp around the cable. That's going to tell us the starter's draw. Starter's always going to draw more as the cylinder comes up on compression, right? We're going to see peaks and valleys in this thing as each of the 8 cylinders comes up on compression. Alrighty, let's add in a trigger now. Now we want to know where we're at on the engine so that if we do have a problem, we'll be able to see it. So I have cylinder 1 right here is already back probed on the ignition coil control circuit from the PCM. And I didn't even grab a wiring diagram for this. I just picked out the odd colored wire. You know, ignition coils are commonly fed power on a common circuit, so I pick out the odd colored wire, and typically that'll be your control side. So hook the lead up to battery ground, hook it into our circuit here. Make sure we're out of the way of our belt again, and hook that up. Okay, so as you can see up on the screen there, we have the amp clamp around our starter cable, positive battery cable, and our trigger is on cylinder 1. So, all right, up on the screen here, I have the lab scope. You can see right here. So blue is going to be signal 1. That is going to be our trigger point, or our cylinder 1 ignition coil. Red is going to be our cranking amperage. I have it set up here 10 volts DC for the ignition circuit, and negative 200 to 500 amp input range for our clamp. All right, let's take a look at what this looks like. So go ahead and crank it over, Fritz. That's good. I'm going to stop it. We don't want to crank it too long. The battery's going to end up dead. All right, so here, 1, 2, 3 spikes. This engine went around 3 times. And you can see we got a pretty consistent reading. Now, on this kind of test, you want to make sure that your battery is fully charged, because having a battery not charged can throw these off. But these spikes right here are actual cylinders hitting top dead center. All right, so I'm going to take and zoom in on this a little bit. So here is cylinder, let's bring this back, go this way. We'll get one event up on the screen. There we go. So this is 1 full revolution of the motor. Cylinder 1 peak right here, so that's cylinder 1 top dead center. And then we just follow firing order from there. So cylinder 1, then cylinder 8, cylinder 7, cylinder 2, cylinder 6, cylinder 5, cylinder 4, cylinder 3, and back to cylinder 1. So this is pretty consistent. And remember, guys, we're just talking relative here. This is relative compression. If the entire engine was down on compression, if the timing was jumped or something like that, you would expect to see this same exact looking thing right here, because it's only relative. You're looking for maybe 1 cylinder or 4 cylinders that are different than the rest. You know, you have one bank that's maybe stuck, that phaser is stuck. You would see 4 either higher or lower than the other 4. Or if you have a valve issue on one cylinder, you would see that here as a lesser hump, or maybe even just a valley there, as it's not causing the starter to draw extra current as that comes up on compression. Okay, so that's a quick and dirty relative compression test. For those of you out there with the Ford IDS scan tool, you can do this right with the scan tool. But I like showing it on the lab scope because it is something that's easy to do, and simple and a quick, easy way to find out, especially for like a misfire. Say you're working on a V motor with the intake manifold over the back 3. Before you go pulling that manifold off, do a relative compression. Verify if you have a mechanical problem on the backside, you know? Something so simple, before you go swapping coils or spark plugs or anything like that, relative compression test. Verify there's no mechanical issues in the engine. So quick and easy way to take care of that. Okay, so I was going to pull a spark plug out and show you guys what that would look like. I'm going to save that for another class just because we're already 40 minutes into this thing, and I still want to pull this intake manifold off and show you guys what's going on. So I think it's about time we do that. I think I talked about everything else that I want to. Let's take a quick peek at my list here. Make sure I didn't miss anything. That looks good. Mass airflow, map sensor kind of things. We're going to be talking about that next class. Now guys, I did lie to you a little bit in the Tech Connect episode. I said that we were going to have a Chevy Colorado in the shop today. Well, after finalizing the classes and figuring out what we all want to talk about, realized that this is going to be a lot longer than I had anticipated, so we're going to do the Colorado next week. We're going to talk about an exact opposite problem, I guess. This was a lean problem at idle. That Colorado is going to be a lean problem under load. So we're going to talk about all of that stuff next class. This class, we're just going to be focused on the GTO. So we'll talk about all that next in May. All right. Oh, one other thing when talking fuel trims. Talk with your customer. You know, always verify with your customer. Is the problem, does anything weird happen with the engine? Does it misfire? Does it stall? Anything like that can really lead you to a certain path to go down. One of the most common ones that I find is the person who backs out of their driveway, right? They put it in reverse, back out of the driveway, put it in drive, and it stalls out right there on the road. Well, remember, every time you're shifting the transmission, that engine can shift in there and move. Well, at that point, you could create a separation in the air intake snorkel right here. If you have a crack in here, like say this baffle or whatever this is cracked, say that was cracked, you shift that motor, now you just created a huge instant vacuum leak that could stall the motor out. So talking to your customer is vital. All right, what do you think, Fritz? Should we pull this manifold quick? Let's go ahead and do it. I'm gonna grab some power tools. Fritz and I are gonna yank this thing off if you guys wanna watch. It'll only take a few minutes. This is a pretty fast one to pull. That's why we're choosing to do it. If it was a pain in the butt, I would have pulled it and taken pictures for you guys, but I think there's some good stuff here to show. So pull out all our tabs and connectors here. Got the fuel off already. Perfect. Yeah, good idea. Pull all our injectors. Now the fuel rail on this one is going to stay with the intake when we pull it off. Pull this out. All right, I'll start taking bolts out. Get this one. Nope. Grab a swivel. Don't need to go stripping bolts out, right? We got the brake booster hose out. Uh-oh. I just dropped one. Is that one back there that I dropped behind the motor? All right, there's all our bolts. I think they're all out. I saw the intake move. I'm gonna take this off take it off the throttle body. Oops. Okay. That's off the throttle body. Pull these connectors. Hey, our CO went off. That's good. Yeah, actually we'll leave these connected. That's off. We got a hose back here. Let's just make sure that we can see if we can find that bolt quick. Otherwise, I don't want it to fall into the.
You find it back.
There we go. I got it. I just don't want it falling into the cylinder when we take this off. All right, so we got everything out of the way. Now, normally, guys, when you're doing this, you'd want to take an air hose, blow off any crap that's on top of the engine, so that when you pull the manifold off, you don't have stuff falling down into the heads. We've already done that. We've had this intake off already. So we've already blown it off. But yeah, just air hose, blow along here. Make sure you don't get any crap down down inside the motor, because that would be bad. All right, now the throttle body. What I'm going to do for the throttle body is, because we have a coolant hose on here, I don't want to disrupt the cooling system on here. It's really your choice for this part. If you want to pull the throttle body, thank you, pull the throttle body with the manifold or without, it's up to you. We're going to pull the throttle body without the manifold. We're going to leave the throttle body attached to its coolant hoses, because this one's only 3 bolts, and we have a new gasket for it. Well, we're about to have a new gasket. It's not here yet. Okay, so there's our throttle body. Now we have all the bolts out. We have the rail attached. We should, everything else is disconnected here. Should be good to go. So, oh, we're still connected to a map sensor back there. So we got some fuel dripping out. I'm going to go ahead and I'm going to tape this fuel line off so when I turn this upside down, we don't dump a bunch of gas. So we're just going to grab some duct tape. Tape this rail off here just as a temporary thing. All right, let's flip this bad boy over. And what I'm going to do, guys, is I'm going to take, if you look at the intake right now overhead, you can see my left hand here, where my thumb is here, is passenger side. This is driver side. When I flip this over, they're going to be opposite. So we're expecting to see valve cover gaskets on this side, which is going to be over here, to look like they're bad. So let's take a look. I'm just going to, actually, let's cover up those holes with a rag quick, and then we'll set the intake right back down on top. Okay, I'll grab some. Now, I don't recommend using your Wells Tech t-shirt for this. Use rags. All right, so I'm going to set this right back down here so that you guys can see what we have going on. All right, so there is our manifold upside down. And right away, I noticed this. Let me grab a pick here so I can point. Right here. You guys can see that, right? Right there is a chunk missing. And right there is a chunk missing. Right here, you can kind of, I don't know if you guys can see that. It's kind of hard to see. But this thing doesn't fit in here anymore, really, right? It looks like it's soaked up something, and it's just not sealing anymore. This side, too, look at this one. It's not down where it belongs anymore. Like, the gasket is too big. And this happens when you have oil leaks, gas leaks, anything that's going to get into that rubber and make it expand. Now, when we pulled this intake manifold off originally, not on camera, our gaskets were not this bad, okay? I did have to exaggerate the problem slightly in order for our smoke to come out of there so you guys could see it on camera. I could see it originally just with the naked eye. There's just some real small little whiffs of smoke coming out. On camera, everything is a little bit harder to see, so I did have to exaggerate those gaskets a little bit so you guys could see it. But basically, we have bad intake gaskets here. So it's what? Let's swap them out and throw some new ones in. So I suppose I didn't give you a pick for your side, did I?
No, it's left behind the t-shirt.
Okay. In fact, I'm actually going to pull this out of the way so that you can clean up the cylinder heads while I'm putting in the new gaskets. Got it? All right. And that's our brake booster hose. We'll get that out of the way. I'll let you wipe those down. All right, so we got some new gaskets here, guys. Just brand new gaskets right out of the box. Can I get one of those rags? I'm going to wipe down our surface here. I'm going to make sure it's nice and clean and dry before I put in our new gaskets. If there's a lot of crud in here, you'd want to clean that out. Maybe clean out the ports, but this one's pretty clean. So I'm just going to start throwing in our new gaskets. And they got a little, I don't know if you guys can see this, maybe. They got a little orientation tab on the gasket. So you just want to make sure that that is in the right spot when you're putting these in. How's that? How do those heads look on there, Fritz?
They look pretty good.
Yeah, they're not too bad. Alrighty. How's that going? I got almost one bank done already.
We're good to go.
All right, nice and clean and dry.
Yep.
All right, I'll finish up this other bank, and then I think we'll be ready to put this back on, right?
Yep.
And now, I would be putting a throttle body gasket in this right now, but we don't have it in our hands quite yet, so we are going to just be reusing the throttle body gasket at this moment. But for the afternoon class, you'll see that I changed that out when we put this back together. All right. Also, the new gasket set came with new foam pieces here that sit over on top of the knock sensors, or over this part here. By the knock sensors, I do have new foam for these as well, but I'm not going to put that on until the second class this afternoon, so that I don't wreck them because they are just stuck on. Okay, so we got everything out of our way here. All of our hoses and connectors are out of the way. Let's throw this thing back in, and hopefully don't get anything stuck between the intake and the cylinder heads. All right, that sits down pretty nice. Feels good. And what I'm doing here, guys, is I'm making sure that it doesn't rock back and forth like there's something stuck underneath it. Set our bolts in here. All right. And I must have set some on the table here. Yep, there we go.
You want to put these on first before you...
Yeah, that's a good idea. Because I did take it off in that order. I'm missing one here. What am I? 1, 2, 3, 4. Oh, right there. Oh, there was a bracket that goes on that one too. Yep. Perfect. Okay, and let's put the throttle body ones in. And again, I would put a gasket in here if we had it in our hand at this moment, but we don't. It'll be going on the next one that we do this afternoon. It's always a good idea to be replacing gaskets when you take them apart, just so you don't end up with vacuum leaks down the road, you know? Fix a problem, create another problem. We don't want that to happen. So I'll go ahead and get these all started. I am going to have to lift this thing up a hair to get those bolts tight on the throttle body. And now I'm just going to run them in until they touch. And then from here, they would get torqued to proper factory spec. I don't think that's measured in ugga-duggas. I think that's what Eric Obrada calls it when he 2 or 3 ugga-duggas. All right, so now, guys, what we want to do is they have to go down a certain way. It's a plastic intake manifold that needs to be torqued down in a certain manner. Have that printed off right here in this sheet of paper. Torque spec, 44 inch-pounds first pass, second pass 89 inch-pounds, and in a certain order, with number 1 being here. So what I'm going to do is I'm going to run them till they touch. Number 2 here. Number 3. And number 4. Number 5. 6. 7. 8. I need a swivel for that one to tighten it down. 9. Or maybe the torque wrench will get in there. And 10. Then I always just go back and do the first 2 again because they typically are a little loose. Okay, so now we brought this intake manifold down properly. Now, Fritz is going to be torquing it down for us. So again, first pass is 44 inch-pounds. Second pass is 89 inch-pounds. So Fritz is going to get that all torqued down to factory spec. And in the meantime, let's take a peek at the comments and see how many people are either sleeping or not here. Holy cow, you guys. Wow. Okay. A lot of comments in here. Awesome, awesome. Let's start at the top. See what you guys are saying. Thanks for the Wells t-shirt, nicer than the one I got at Menards. All right. Well, Mace118, I'm glad you like your shirt, and I'm glad we could get that to you. Good morning from Saudi Arabia. Terry is ready to go. Mark says good starting. We got a couple answers to the t-shirt question. Terry, rich because the gas is already used and will not burn. Running a little late this morning, said Mike. Bob is here saying MAP or mass airflow. And actually, Bob, that's a great question. MAP or mass airflow engine will affect how that EGR problem occurs. So I didn't bring that up on purpose, guys, because I wanted somebody to call that out. I guess let's talk about the answer. So the answer is that the engine will typically run rich, right? So what does rich mean again? Rich means there's a lack of oxygen, that's vital, lack of oxygen going past the oxygen sensors. Simple. What does an EGR valve do? Takes fully burned, hopefully fully burned exhaust gases, recycles them into the engine's intake manifold. Okay? At that point, what is that EGR gas doing? It is displacing oxygen that could be in the intake manifold, right? So now your mixture is now diluted with EGR gas, meaning there's less room for oxygen inside of your mixture, meaning that your system will run rich. Lack of oxygen past the oxygen sensor because it's being diluted by a mixture of EGR which has no oxygen or very, 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 very little oxygen in it. Now, the question about mass airflow map sensor. A map sensor engine will take this problem. Uh-oh, did it just reset? Yeah. It does that sometimes. A map sensor engine will take this problem and just compound on top of it. It'll see a leaking, stuck open EGR valve, and it'll see a dip in engine vacuum, thinking that it's under throttle at that point, and it'll increase fuel even more. So not only is it going to run rich because the engine is being flooded with EGR gas, but now it's actually being flooded with fuel as well on a speed density style system. A mass airflow style system can probably handle a stuck open EGR even better. And don't forget that most modern EGRs do have position sensors in them, so they would most likely set a code at that point and could potentially not even set a rich or lean condition. So guys, I want your answers, and if you have good reasoning behind it, I'd be happy to send you a t-shirt or a hat. Again, bring up my email address on the screen for me, please. T-shirt or hat, shirt size, mailing address, and the color that you want. We only have black hats, and they're only in one size, but for the t-shirt, if you'd like one of those, send me out an email. It shut off again, didn't it? Oh, okay. All right. So that's all good to go. Let's look at these comments a little bit more. Looks like Keith is here. Onboard Tech 333 actions should be mostly burnt in the combustion process. Exactly. All right, everybody's saying hi to each other. Because a rich condition, it looks like a lot of you guys know. But again, Paul here is saying that it would cause a lean condition on a mass airflow sensor. I'd be interested to hear what the thinking is behind that. And actually, that's what Onboard Tech 333 says right here. What's your thinking behind that, Paul? So it'd be interesting to see what you guys have to say in your emails. I will read through each of these comments. It looks like Bob gets into it pretty in-depth here, talking about it. Mohammed's here. Awesome. Drew is here asking what he missed. All right. And remember, guys, these live broadcasts, they're always going to be recorded as they are recorded immediately, and as soon as they're done live, you are able to access it out on the out on YouTube, right? So if you missed something, if you want to go back and see something, if you're just wondering how something was done, you can always access this again right on YouTube, right where you found it right now. If you're watching on our website, it is going to be, you're going to have to go out to YouTube to find it. You can find that through the past broadcast tab. How we doing there? Good. Okay. I'll help get some of this hooked up here, and then we can hopefully get this thing running pretty quick. And get our injectors hooked up.
Just got to get the mass airflow in the back.
All right. Get this guy hooked up. Where was that hose that was attached to this? Right here? Okay. Is that map sensor's not plugged in back here? Okay. All right. Always put your clips back in for your harnesses, guys. Right here and here. These are important. This one and this one. That's all right. There we go. These guys right here, these are important. They hold your wiring harness in place. They're very important. They can create all kinds of problems if you don't get those back in. That harness is meant to stay in place. All right. We all torqued down. Good to go. Torque to factory spec. Get our throttle cable put back in. Thanks for doing that, Fritz. I don't think people want to watch how to torque an engine or an intake manifold. And so that's hooked up. Our throttle body is good to go. Get this guy back on. And we should be just about good to go. I'm going to get the intake air temp sensor put back on this side that you guys can't see. It's on the other side of the snorkel right here, just on the opposite side. Get that plugged in. Grab 8mm. Run these back down tight. And I think we should be just about good to go. clamp is stuck. There we go. All right, and now at this point I would go over every bolt and just make sure like this stuff is all tight with a 1/4 inch ratchet or something like that. Injectors are all plugged in, purge is back on, plugged in, our hoses are good to go. I think we're just about ready to fire this thing up. Brake booster hose is back on. All right. One more thing. Now at this point, you want to just turn the key on, Fritz, for me? That'd be great. I'm going to get this out of the way. All right, so key on right now, guys. Let's look at those fuel trims again. Now we have one of two options here. Maybe. Are we still plugged in? Is the key all the way on? I got no communication. Okay. There we go. All right, so now we can see, because our key is just on right now, long term's 22 and 15, short term 0, because our short terms always go back to 0. Now you have one of two options to do here, guys. You could clear the codes, reset the field trims, fire this thing up and see if it runs perfect. Or what I prefer to do is fire it up as it was running before and watch the computer correct, and hopefully eventually, if everything's fixed properly here, fingers crossed, if everything's fixed properly, it will go right back to where it is right where it's supposed to, back under that plus or minus 10. All right, I'm going to grab the fuel pump fuse, throw this one back in. You want to go ahead and prime the fuel system. Get the rail back full of fuel. And I think we should be just about good to go. All right, let me go ahead and fire it up and I'll get the scan tool loaded. All right, bring up the scan tool as soon as it loads here. And there we go. I'm going to bring this down into graph view for you guys. And we should see some corrections start to happen. So look at our O2 sensors already, right? Bank 1, Bank 2 and Bank 1 sensors are really, really rich right now, right? They're almost pegged. That right there is telling me that our problem is probably fixed. And look at our short term start to go. Look at that. They're starting to react. We just went into closed loop. Oh, had to get a drink of water. We just went into closed loop. Our long terms are beginning to respond. Where's our other one? There it is. Long terms are beginning to respond. Starting to drop down. Our short terms are almost down to where they belong. Our short terms are still negative. Remember, guys, the whole goal of short-term fuel trims are to bring those long terms to their happy point. Now what I would do at this point is I would take this thing out and drive it and see how it reacts, clear the codes, and should be good to go. Our long terms are still pretty high here. I would like to see these come down a little further. At this point I clear codes and drive it and make sure we're good to go, but significant improvement over before. I don't think there's anything else wrong with this engine, but if I do find something else wrong with it, I'll let you guys know in the next class. But as of right now, I think we're good to go. So you can go ahead and shut it off. I think that is probably going to be about it for today, guys. I do have something very important to bring up here at the end that I've been waiting all class to talk about. Was there anything else you think that I missed?
I don't think so.
Okay. All right. Fuel trims are very, very common codes, guys. Lean codes being the most common, rich codes less likely, still possible, but less likely. There's a lot of different paths, a lot of different situations that could cause lean or rich concerns. It's all about getting information, knowing what you're looking at, and then picking a path to go. You know, do you take the left path or the right path? If you pick the wrong path, you could end up wasting a bunch of time. You know, it's all about knowing what you're looking at and choosing. And you know, when we looked at coolant temperature and if this thing was running lean at idle or under load, that really helped us choose that path. You know, we didn't have to check fuel pressure on here. We didn't have to really look at cranking compression or anything like that because we knew we had both codes. We had a problem at idle. It's all about picking that path and going down that road. Now, with experience comes these choices become easier to make. But it's just something that you'll learn, and sometimes you might get burned on it, sometimes you might not. It'll all depend on your experience. So, all right, I think that's going to be about it for today, guys. Now, what I want to talk about is a new little contest that we're having. Now, on our website right now, if you haven't been there, wellsve.com, Wells Vehicle Electronics, ve.com, on our webcast page at the top, there's this little button called Survey. I want you guys to go out and take our webcast survey. It's only, I think, 8 questions. It'll take you less than 2 minutes to do it. Everybody who enters and takes that survey fills out all the information on there between today, April 6th, and June 1st, the class that we're having on June 1st, will be entered to win one of these super awesome Wells Tech work shirts or bowling shirts or whatever you guys want to call them. You'll be entered to win one of these shirts with your name on it right here. If your name is Mike, it'll be real easy. I'd love to send you one out, but we will get them custom made with your name on it. So take our survey. I will throw that link into the description of this video here in just a few minutes. It will be in the description. Anybody who takes this, you don't have to be watching live today. Anybody who watches our training between now, April 6th, and June 1st of this year, 2017, takes the survey, fills it out, answers all the questions, you will be entered to win one of these work shirts right here, okay? So, all right, I think that's about it. What do you think, Fritz?
I think so.
Good to go? Next week, or excuse me, next month, guys, in May, we're going to be finally concluding fuel trims. We're going to work on that Chevy Colorado that's going to be over there for a lean condition as well, this one under load. A little bit different diagnostic approach on that one. So we're going to talk about that next month. Until then, guys, check us out on Facebook, Instagram, Twitter, LinkedIn, YouTube, all the social media. We're out there, Wells Vehicle Electronics. Search for us, retweet, friend, share, follow, thumbs up. I'm probably missing some here. But check us out there. We're updating those pages constantly. And for all the questions and different things that you guys answered in questions here, make sure to check back on the Tech Connect episode that will be coming out the Friday before May's class. That's always the week before, the Friday before the class, the next upcoming class, okay? So, all right, guys. Well, thank you for sticking with me. I know it's been almost an hour and 10 minutes here. This was another long class, but definitely please take that survey. Let me know what you guys think of our training, and enter to win one of these shirts. So, thanks for sticking with me, and we'll see you guys again next time. Thank you.